Concepts of object-oriented programming. Java. C#, C++, Delphi. In this video we will be explaining how the object-oriented programming concepts are implemented in different languages. Object-oriented programming concepts. Encapsulation, abstraction, inheritance, polymorphism. How are these implemented in different programming languages? What is encapsulation? Encapsulation is an attribute of object design. It means that all of the object's data is contained and hidden in the object and access to it restricted to members of that class. Public. All objects can access it. Protected. Access is limited to members of the same class or descendants. Private. Access is limited to members of the same class. Internal. Access is limited to the current assembly. Protected. Internal. Access is limited to the current assembly or types derived from the containing class. Encapsulation. Java. Encapsulation is used in a Java program nearly the same way as it is used in a C++ program, except different syntax applies. Let's take a look at how encapsulation works in Java. Also, we must make behaviors that access and modify the state of the object. This can be accomplished in three ways. Constructor methods. The new instance of an object is created by calling a constructor method. Values can be passed to a constructor method to set the initial state of an object. There are two interesting things to note. 1. Java does not insist that every object has a constructor method. If no method exists, then the state of the object uses the default values of the private fields. 2. More than one constructor method can exist. The methods will differ in terms of the values that are passed to them and how they set the initial state of the object. Accessor methods. For every private field we can create a public method that will return its value. Mutator methods. For every private field we can create a public method that will set its value. If you want a private field to be read only, do not create a mutator method for it. The OO principle is that all of the functions and only the functions that access the internal representation of a type should be encapsulated within a type definition. C++ supports this via member functions and friend functions but does not enforce it. The programmer can declare parts or all of the representation of a type to be public, and is allowed to make public entities that are not part of the representation of the type. Therefore, C++ supports not just OO programming, but other weaker decomposition paradigms, like modular programming. Encapsulation. C. In C, a function is clearly encapsulated. Its implementation is inaccessible to other parts of the program and protected from whatever actions might be taken outside the body of the function. Method implementations are similarly encapsulated, but, more importantly, so are an object's instance variables. What is abstraction? Abstraction is the process by which data and programs are defined with a representation similar in form to its meaning, while hiding away the implementation details. Abstraction Java. Abstraction in Java refers to the ability to make a class abstract in OOP. An abstract class is one that cannot be instantiated. Java has concept of abstract classes, abstract method, but a variable can't not be abstract. Example abstract class. Abstraction, C#. Almost similar to Java's abstraction class. Here is an example code. Abstraction, Delphi. What is inheritance? Inheritance is a way to reuse code of existing objects. Establish a subtype from an existing object, for both, depending upon programming language support. Inheritance, Java. Inheritance defines relationships among classes in an object-oriented language. In the Java programming language, all classes descend from Java.Lang object and implement its methods. Inheritance, C++. Multiple inheritance is a C++ feature not found in most other languages, allowing a class to be derived from more than one base classes. This allows for more elaborate inheritance relationships. Inheritance, Delphi. Multiple inheritance Delphi, like Java and unlike C++, does not implement multiple inheritance. To achieve an effect similar to multiple inheritance in Delphi or Java, we can use composition and /or interfaces. Composition, while inheritance is very powerful and useful, it is not the only way to reuse existing classes, and in some situations composition is preferable. Composition is a way to combine a group of objects to create a super object. Delphi uses it extensively in generating user interface forms. What is polymorphism? Polymorphism is the ability to create a variable, a function, or an object that has more than one form. The word derives from the Greek pfs meaning having multiple forms. In principle, Polymorphism can however arise in other computing contexts, and it shares important similarities to the concept of degeneracy in biology. Polymorphism. Java has excellent support of polymorphism in terms of inheritance, method overloading and method overriding. Method overriding allows Java to invoke method based on a particular object at runtime instead of declared type while coding. Parametric polymorphism in Java. Java started to support parametric polymorphism with introduction of generic in JDK 1.5. Collection classes in JDK 1.5 are written using generic type, which allows collections to hold any type of object in runtime without any change in code, and this has been achieved by passing actual type as parameter. For example, see the below code of a parametric cache written using generic, which shows use of parametric polymorphism in Java. Polymorphism. C++. C++ supports several kinds of static compile time and dynamic runtime polymorphisms. Compile time polymorphism does not allow for certain runtime decisions, while runtime polymorphism typically incurs a performance penalty. Polymorphism. C#. C# gives us polymorphism through inheritance. C# provides a keyword virtual that is used in the definition of a method to support polymorphism. If the method is not virtual, the compiler simply uses the reference type to invoke the appropriate method. When a virtual method is called, runtime check late method binding is made to identify the object and appropriate method is invoked. All this is done at runtime. Drawbacks of object-oriented programming. Larger file sizes. Object-oriented programs are much larger than other programs in the early days of computing. Space on hard drives, floppy drives and in memory was at a premium. These restrictions do not affect today. Increased work effort. Object-oriented programs require a lot of work to create specifically. A great deal of planning goes into an object-oriented program well before a single piece of code is ever written. Lack of performance. Object-oriented programs are slower than other programs, partially because of their size. Other aspects of object-oriented programs such as class hierarchy, number of objects created etc. also demand more system resources, thus slowing the program down. Separation of data and operations. In an object-oriented program, data and operations are separated. Therefore, to access data, operations have to search the data extensively, which increases compile time of the program, ultimately lowers performance. Inadequate for concurrent problems. When object-oriented programs are used to handle concurrent operations, problems arise since there may not be any built-in mechanism to handle concurrent operations. Programmers have to implement extra coding to handle concurrent situations. More coding means increased amount of work. Lack of expressivity. An object is an encapsulated entity that has precisely known relations to other entities. Encapsulation property can sometimes have drawbacks because it hides data. Object-oriented approach to a problem that cannot be expressed as such. An entity relationship model will likely fail or at least exhibit severe performance drawbacks. Memory management issues. Objects are usually allocated separately, and when many, especially small objects, are allocated, the main memory becomes cluttered with those small allocated structures. Inflexibility to change. Before using object-oriented programming method, designs have to be planned thoroughly. As an example, when designing business-based software, customers may change their requirements often due to changes in their business situation. Since object-oriented programming design is static, customers' rapid changes cannot be adapted easily into design. Not suitable for any problem. Object-oriented programming method is neat, clear and efficient for solutions to large problems because of the performance issues. Object-oriented programs are not even used at present for programming in small mechanical devices, e.g., microcontroller programming. Known problems of object-oriented programming. Fragile binary interface problem. The fragile binary interface problem, or FBI, is a shortcoming of certain object-oriented programming language compilers, in which internal changes to an underlying class library can cause descendant libraries or programs to cease working. It is an example of software brittleness. The problem occurs due to a shortcut used with compilers for many common object-oriented OO languages, a design feature that was kept when OO languages were evolving from earlier non-OO structured programming languages such as C and Pascal. Fragile base class problem. A fundamental architectural problem of object-oriented programming systems where superclasses are considered fragile because seemingly safe modifications to a base class, when inherited by the derived classes, may cause the derived classes to malfunction. The programmer cannot determine whether a base class change is safe simply by examining in isolation the methods of the base class. Diamond problem. In object-oriented programming languages with multiple inheritance, the diamond problem, sometimes referred to as the deadly diamond of death, is an ambiguity that arises when two classes B and C inherit from A, and class D inherits from both B and C. If D calls the method defined in A and does not override the method, and B and C have overridden that method differently, then from which class does it inherit, B or C? The circle-ellipse problem. The circle-ellipse problem in software development, sometimes known as the square-rectangle problem, illustrates a number of pitfalls which can arise when using subtype polymorphism in object model.